In this presentation, I am analyzing the quiz problems. So in this quiz, there are three main units which we are using. The one is the volume unit, and the other is the pressure unit, and the third one is the temperature unit. So these are the three units are used in this quiz. So for the volume unit, the SI unit of the volume is meter cube. It means in every problem you have to use the unit in meter cube. If the other unit is given, you have to change to this meter cube. And for the temperature, the SI unit is Kelvin. So if the temperature is given in degree centigrade, you have to change to the Kelvin. And for the pressure, the SI unit of the pressure is the Pascal. You have to change the unit in Pascal. And this 1 Pascal is equal to the Newton over meter square. It has the same meaning here. Now for the volume unit, here some unit conversions are given. Like here, the 1 liter is equal to 10 to the power 3 centimeter cube. So this is one conversion. If liter is given, you can change to meter cube, or if the meter cube is given, you can change to the liter. And the second one is 1 liter is equal to 10 to the power minus 3 meter cube. So this also you can change from liter to meter cube or meter cube to liter. And here 1 meter cube is equal to 10 to the power 6 centimeter cube. And here 1 meter cube is equal to 10 to the power 9 millimeter cube. So the rule, what the unit are given here in this yellow box. So how to change the unit? So if I take anything from here, like if this is 1 liter, and this 1 liter is equal to 10 to the power minus 3, and this is meter cube. So if you are changing from this side to that side, then you have to multiply. If you are changing liter to meter cube, then you have to multiply. And if you are changing meter cube to liter, then you have to divide. For example, if the volume is given 5 liter, then you have to change this liter into the meter cube. So how to change this one? Now you are changing this liter to meter cube. Liter to meter cube means like you are changing this from here liter to this liter to meter cube. So you have to multiply by this number like this. So here this is equal to, this is 5, and here this is 10 to the power minus 3, and this will be converted to meter cube. So the meaning is this 5 liter is equal to 10 to the power minus 3, and this is meter cube. So in the same way you have to change all the units. If you are moving this side to this side, then you have to multiply, and if you are moving from here to here, then you have to divide by this number like that. And for the atmosphere, so this Pascal is the SI unit. This Pascal is the SI unit. So if any unit is given, you have to change to the Pascal. And here 1 atmosphere is 101.3 kilopascal, or this is also equal to 1.013 into 10 to the power 5 Pascal. So, and this is 1 unit, this is 1 unit here, and this is second unit, and this is third unit. So if the value of the pressure is given in Pascal, no need to change, and if the value of the pressure is given in atmosphere, you have to change to the Pascal. And if it is given in bar, so you have to change to the Pascal. Like here, if you are changing this bar to Pascal, so you have to multiply by this number, and if you are changing the Pascal to the bar, then you have to divide the number by this number like this. Sometimes the volume is used with a liter, and the liter is used with some prefix, like sometimes this volume may be used with milliliter, or it may be used the microliter, it may be used with the kiloliter, or it may be used with the nanoliter, or it may be used with the megaliter. So this, whatever it is written here, like this is milli, this is micro, and this is kilo, nano, mega. These are known as the prefix. It has some value. Like for the milli, if milli is coming, the meaning of the milli means it is 10 to the power minus 3. And if it is coming micro, the meaning of the micro means it is 10 to the power minus 6. And if the kilo is coming, the meaning of the kilo means 10 to the power 3. And the meaning of the nano, it is 10 to the power minus 9. And the number for mega, it is 10 to the power 6. So if the volume unit is used with this prefix, so first you have to change this prefix. Like for example, if the volume is given, this is 8 milliliter, so this 8 milliliter you cannot use for any calculation. You have to change this 8 milliliter unit to the meter cube, to the standard unit of the volume, then you can use. So directly you cannot change this 8 milliliter to the meter cube. So what you can do, first you change this milliliter into the liter, and then this liter you change to the meter cube. So if you are changing here this milli, so this milli means 10 to the power 3. So at the place of this milli you write 10 to the power 3. So here in liter, this volume will be, this is 8 multiplied by 10 to the power minus 3 liter. Now this liter, this is your number. Now in liter, how much this one? This is 8 into 10 to the power minus 3 liter. Now this liter number you have to change to meter cube. Now the rule between the relation between the liter and the meter cube is that 1 liter, this is 1 liter is equal to 10 to the power minus 3, and this is meter cube. So if you are changing from liter to meter cube, then you have to multiply by this number, and if you are changing from meter cube to liter, then you have to divide by this number, like this. This is the rule to change from liter to meter cube or meter cube to liter. Now here the number is this one. So this is 8 into 10 to the power minus 3. So this is the number in liter. Now we are changing this liter to meter cube. So further you have to multiply this number by 10 to the power by this number 10 to the power minus 3, then it will be converted to the meter cube. So if I calculate this one, so this is 8 into 10 to the power minus 6, and this is meter cube. So the meaning is the volume, which is 8 milliliter, this is equal to 8 into 10 to the power minus 6 meter cube. So in the same way you have to change like all the prefix. Like here I have taken the example of the milli. If this is kilo, so if the volume is given like this, okay, the volume is 15, this is kiloliter, so you have to change to meter cube. So what you have to do, first you change this kilo. Okay, so the kilo means it is 10 to the power 3, and this is your number. So first you write your number. So this 15 is here, and this is 10 to the power 3. So now the number here, this number is in the unit of liter now, and this liter again you have to change to meter cube. So again you have to multiply by 10 to the power minus 3. Then it will be converted to meter cube. So here the answer will be, this is 15 and this is meter cube. So the volume the volume 15 kiloliter is equal to 15 meter cube. So the meaning is first you have to change the prefix. Prefix means first you have to change this milli, first you have to change this micro, first you have to change this kilo, first you have to change this nano, and first you have to change this mega. So your volume will be converted to liter, and then after that you change this to the meter cube by multiplying 10 to the power minus 3 like this, okay, in meter cube. Like all you have to change in meter cube like this. Now here multiple choice questions are given, and the question number 1 is 675 microliter of propane gas is equal to how much? So first you have to check, like in the options, which unit is given or the units are given. So here if you see, like in the options, all the units are given in meter cube. So you have to change this thing into the meter cube. Now the here it is, the value is given, it is 675 microliter. So this you have to change into the meter cube. Now here this prefix is used, this is micro, and the meaning of this micro means this is 10 to the power minus 6. So first you have to change this prefix micro. So your value of this volume in liter will be this is 675 into 10 to the power minus 6 liter. Now you change this liter to meter cube, and the rule for the liter to meter cube is that 1 liter is equal to 10 to the power minus 3, and this is meter cube. Now already I told you, if you are changing from liter to meter cube, you have to multiply by this number, and if you are changing meter cube to liter, you have to divide by this number. So you are changing this to the meter cube. So your answer will be, this is your number here, this is your number in liter. So write this number, this is 675 into 10 to the power minus 6, and because you are changing this liter to meter cube, so again you have to multiply by this number. So it is 10 to the power minus 3, and this total will come, this is 675 into 10 to the power minus 9, and this will be meter cube. So if you see this power, so this 10 to the power minus 9, it is not coming here, it is coming 10 to the power 3, and here it minus 6, and here it is coming minus 4. So little bit you have to change this number in the form which it is given here. Now this is meter cube, and here this is meter cube. So here there is no power, so this number and this number is not matching. And here this some power is coming here, so this power is not same here. So what we can do, I can write this number like this. This is 675 into 10 to the power, this is minus 3, and this is 10 to the power minus 6, and this is again, this is meter cube. So likewise here it is coming minus 6, and here I am getting the minus 6. I am splitting this power like this way, minus 9 in the form of the minus 6 and minus 3. Now if I calculate this number, so this will be 0.675 into 10 to the power minus 6, and this will come in meter cube. So here this is the correct number we are getting here. So this is the correct option. So this option is the correct one. This is the correct option here. So the question number 2, on the basis of the given diagram, they are talking about this diagram. At 300 Kelvin temperature, the volume is. So the question is asking at the 300 Kelvin temperature, what is the value of the volume? So this 300 Kelvin is this temperature, this one. So from here, okay, so how to find the volume at this temperature? So from this point you go up, and where this line is cutting this graph, so it is cutting here, and then you move to the volume axis. So where it is touching the volume axis, so this is the value. This is the value of the volume at this temperature, at 300 Kelvin temperature. So for this question, for this second question, the temperature is 300 Kelvin and the volume is 300 milliliter. But this answer 300 milliliter, this option is not matching here. Not in this A, not in this B, not in this C. But here this one option is there, the option number D. So the option number D is saying the A and the C both are correct. So this type of question where in the options there are more than one options are correct. So what you can do, first you check this number, this number is equal to 300 milliliter or not, then it will be correct or not. So you have to check the option A and the option C, this is equal to coming 300 milliliter or not coming. So here I am taking this option A. So what is this option A? This option A is, this is 3 and here 5 times zeros are there. So this is 5 times 0. So I can write like this. So this is 3 into 10 to the power 5 and this is microliter. So this micro also I am changing. So here this is 3 into 10 to the power 5 and micro means it is. So here the micro means it is 10 to the power minus 6 and this is a liter. So what I will do now, I will change this to milliliter and then check it is coming 300 or not 300. So what I am doing, I am breaking this power, this 10 minus 6. So I can write this number like this. So this is 3 into 10 to the power 5 and here this is 10 to the power minus 3 and here this is 10 to the power minus 3 and this is liter. So this minus 6, it is minus 3 and minus 3 here. So now this 10 to the power minus 3, I can make this as a milli and I will calculate this number how much it is coming. So if I am calculating this power and this number, so it is coming 300 milli. This is coming 300. So it is coming 300 and this milli is coming from here. This is milli and this is liter. So it means this option is the correct option. Now we will check for like this C is correct or not correct. So here the C option given here, this is 0.000 and this is 3 and this is kiloliter. So if I change this kilo means, this kilo means 10 to the power 3. So if I multiply this number, so it will be 0.3 and it is liter. Now what I am doing here, I have to check with the milliliter, it is how much it will be in milliliter. Now this one milli is equal to 10 to the power minus 3. If you are changing this milli, so you multiply by this number, and if you have some number and you are changing to milli, like this number you have and this you are changing to milli, then you divide by this number, then divide. So what I am doing, I am having here number. I am having here number, and I want to change this number to milliliter. So what I will do, I will divide like this. So I will, because I am changing from number to milli, so I will divide this number. So here this is 0.3 and this is 10 to the power minus 3. So I will write here milliliter, and this will be, when I will solve this bracket, so it will be 300, and this is milliliter. So this is also equal to this number is also equal to 300 milliliters. So it means this is also correct. So it means the option, this C is correct and this A is correct. So the meaning is the D option, the option A and the C both are correct, like this. This is the ultimately correct answer here. Now this is saying, okay, how much it is coming? This is coming milliliter. So this is 300 milliliter, and here the option B is 30 milliliter. So this option is not correct. So this way you can find if one or more than one options are correct in the question. So in this question, a helium gas occupies 10.5 liter at a pressure of 70 millimeter of mercury. What is the volume when the pressure is increased to 71 millimeter of mercury at the constant temperature? So here in this question, the question is telling the temperature is constant here. So the direct meaning of this, that you have to use the Boyle's law. This is a clear meaning which is coming from the constant temperature. So in this question, the helium gas 10.5 liter. So this is the volume, this is the initial volume at the pressure. So this is the pressure of 70 millimeter of mercury. Actually, this value is not the pressure value. This value is the height of the barometer. Here you see here, this is the device barometer. It is telling the pressure. So this device is used to find the pressure by using this formula. So this formula you have to use. So in this question it is written the pressure of 70 millimeter of mercury. We say like that, this is the language of the question to define the pressure. How much is the pressure? So we say the pressure is 70 millimeter of the mercury. But this is not the value that you can use for the calculation. You have to use the barometer formula. This formula you have to use, and you have to get the value this by using this into the pressure value. So this H is what here? This H is this one. This H is what here? This H is the value of this H, this one. So this is the height. This is not a pressure. So this is the height, and this height you can take only in the unit of meter. So like this way. And so what is the volume? What is the volume? So here you have to find another volume. Okay, what is the volume means final volume you have to find. What is the volume when the pressure is increased to? So this is another pressure value, final pressure, and it is coming at 71 millimeter of the mercury. So again, this is not the pressure value. This is the value of the height of this barometer. So now what the parameter given here? So we collect the parameter. So the volume is given. This is the initial volume, and the volume is, this is 10.5 liter. So this liter you cannot use, and the final volume you have to find out. This volume you have to find out. And now the pressure, this pressure value given, this is the initial pressure. But for this pressure, the exact pressure value is not given. So for this pressure value, the value of the H is given. This H is 70 millimeter of mercury. So this we will use the density of the mercury here. So first you have to change this millimeter to meter. Now the relation between the millimeter and the meter is that 1 meter is equal to 10 to the power 3, and this is millimeter. So now the same rule you have to use if you are moving from left hand side to the right hand side like this. If you are moving from here to here, you multiply by this number, and if you are moving from millimeter to meter, you are changing millimeter to meter, then you have to divide by the same number, this number. So we are what we are changing here, we are changing this milliliter to meter. Now so we will I will use this divisor. So this h is equal to, this is 70 into 10 to the power minus 3 in meter. So this is the value of the height of this barometer in meter. Now to find the value of this pi, the pressure, you have to use this formula. This formula you have to use. Now this is pi, and this is height, this height. So I will say this is like, I will say this is initial height because we are calculating I, so I will say here I, and this is d, and this is g. So here this d is constant. So here this d is the density of the, this is the density of the mercury, and this value is, this is a constant value, so this is 13,600, and this is kilogram over meter cube. So this value will be given to you, this is a constant value. So when I will put all the values here, so this is 70 into 10 to the power minus 3, and here it is 13,600, and this is multiplied by 9.8. So when you will calculate this value, so the answer will come, this is 9329.6, and it will come in Pascal. So this way we can calculate. Now in the same way, this PF is also given. This is the PF. So here the PF is, here this PF is given. For this the value of the height is given, the pressure is, this is 71, and this is millimeter of the mercury. So the meaning is, this is the value of the height of this barometer. So this is F I am using here, so this is HF, and the value of the HF in meter, it will be 10 to the power, so this is here it is 10 to the power minus 3, so it is multiplied by 71, and this will be meter cube. So you have to use the formula for the same formula we are using here for the F. So it will be like this. So this is PF equal to, this is HF, and this is D, and this is G. So when you will put the value of this H, so this is 71 into 10 to the power minus 3, and this is the density of the mercury, and this is 13,600, and multiply by 9.8. So this pressure value will come, it will come 9462. So it will come 9462.8 Pascal. So it will come in Pascal. And this volume also you have to change in meter cube. So this will be 10.5 into 10 to the power minus 3, and this is meter cube. Now you have to use the Boyle's formula for this. Now the Boyle's law is this one. The Boyle's law is, this is Pi and it is Vi equal to, this is Pf and this is Vf. So here you have to find this Vf. Then if I change this equation, so it will come like this. So this Vf is equal to, this is Pi and this is Vi over this is Pf. So first you have to rearrange the equation. Which parameter you have to find, you keep this side and all other side. Now this Vf equal to, so put the value of the pressure of Pi. So this is 932 9.6, and the volume which is given to us, this is 10.5 into 10 to the power minus 3, and it is divided by the Pf. So this Pf is 9462.8. So when you will calculate this, the value of the Vf, it will come, this is 0.0103, and this is meter cube. So this way you can get the answer for the final volume. So this is 0.0103, and this is meter cube. So this is the answer of the volume in the standard unit. Now if, here I am saying if, okay, if the question is saying you find the answer, you find the volume in the unit of the liter. So how you can change this to the liter? Okay, now the formula for the meter cube and the liter is that 1 liter is equal to 10 to the power minus 3, and this is meter cube. Now what you are doing, you are changing from here to here like this. You are changing from here to here, so you have to divide. Now this number is coming, this is 0.0103. So you divide by, this is 10 to the power minus 3. So it will be, when you will calculate this one, so it will go like this. So here it will come 0.3 liters. So in the form of the liter, also in the form of the meter cube, the answer is this number. This is the number in the meter cube. You have to find in the standard unit meter cube. But if the question is saying you find the answer in the liter, so by using this rule you can change this meter cube to liter also. If it is in the liter, so this answer will come. So in this question, on a cold winter morning when freezing temperature is minus 10 degrees centigrade, so this one temperature is given here. The air pressure in the automobile tire is 1.5 atmosphere. So this here the pressure value is given. If the volume does not change, so this volume is not changing here. So it means this volume is constant. This volume is not changing. The pressure after the tire has warmed means heated to 10 degrees centigrade. So this is also temperature is given. So here this is, it means this is first, so this is the initial temperature, here it is the final temperature, and here this is the initial pressure. So the question is saying on a cold winter morning when the freezing temperature is minus 10 degrees centigrade, the air pressure in the automobile tire is 1.5 atmosphere. If the volume does not change or it is constant, the pressure after the tire has warmed up to this. So what is the value of the pressure when, what is the value of this pressure when the tire temperature is warm to 10 degrees centigrade? So here you have to find the pressure value. So what are the given parameter here? First you write. So this is the temperature, it is the initial temperature, and this is minus 10 degrees centigrade. So degree centigrade you cannot use. So here this is minus 10 and plus you have to change to Kelvin. So this is minus 273. So this is 263 Kelvin like this. And here the temperature, the final temperature is, this is 10 degrees centigrade. So this is plus 10. So this is 10 degrees centigrade. So meaning is it is a plus. So you have to change this degree centigrade to the Kelvin. So this is 10 degrees centigrade plus this is 200. You have to add 273. all the time. This number you have to add all the time in degree centigrade to change to the Kelvin temperature. So this will come, this is 283 Kelvin. So we will use these two values. Now here the pressure, the initial pressure is given, this is 1.5 atmosphere. So this atmosphere also you cannot use, and this atmosphere you have to change in the unit of the Pascal. Now the relation between the atmosphere and the Pascal is that 1 atmosphere is equal to 1.013 into 10 to the power 5, and this is Pascal. So the meaning is, if you are moving from here, from the left hand side, this is the left hand side, this is the left hand side. If you are moving from left hand side to the right hand side, you multiply by this number to the given number, and if you are moving from Pascal to atmosphere, so you divide like that. So here, by using this rule, the initial value of the pressure is, this is 1.5 multiplied by, this is 1.013 into 10 to the power 5 Pascal. So this value is coming for the initial pressure Pascal. Now here the rule is, this volume is constant, so this volume is coming constant here. So in the Gay-Lussac law, the law is, the law here we have to use the law here we have to use, the name of the law is the Gay-Lussac law. So this law we have to use, this is the Gay-Lussac law. Gay-Lussac law, or we can say this is the pressure law. It has the same meaning, and the law is, this is initial pressure over this is initial temperature is equal to the final pressure over this is final temperature. Now here you have to find the value of the final pressure. This value you have to find. So it means, take this side here, and this side will be like this side, it will go this side, and this will be like this. This is the initial, this is the final pressure, and this is Pi. After the cross multiplication, this is Pi, and this is Tf, and here it will come Ti like this. So this is the formula here, and after putting the values of the Pi, this Pi value, this is 1.5 into 1.013 into 10 to the power 5, and the final temperature is, this is 283, and you divide this one by this Ti. So the Ti is, it is 263. So after, whenever you are calculating in your calculator, so take care, you keep all the values in one bracket, then you divide this value. So here the value of the Pf, it will come, this will come 163.5 into 10 to the power 3 Pascal. So here the answer will come in Pascal. So this is the our answer here. This is the answer. So here in this question, what is a barometer, and draw the diagram. So here I told you what in the previous slides, what is a barometer, and the diagram also I have shown. So here you have to give the definition of the barometer. What is the barometer? The barometer is a device which is used to measure the atmospheric pressure. So this device, this barometer is used for the pressure measurement, to find the pressure by using this formula. So there is a formula for this. So the pressure formula is P equal to H, and this is D, and this is G. So this formula we have to use to find the pressure from the barometer machine. So in this formula, this H stands for the height of the mercury, and this D is constant. This is the density of the mercury. This will be given to you, and this G is the gravity, 9.8. So here in this the part B, calculate the pressure, atmospheric pressure of the air in Pascal. So you have to find the atmospheric pressure P in Pascal. Height of the mercury. The height of the mercury means the H is given to you. So this is the value of the H. So here the H is given. So this H is given 650 millimeter. But this H you have to use in meter. So the relation between the meter and the millimeter is that 1 meter is equal to 10 to the power 3, and this is 1000 millimeter. Now the rule is, if you are moving from left hand side to the right hand side, you have to multiply by this number, and if you are moving from this millimeter to, if you are changing from millimeter to meter, you have to divide by this number, by this number. So here you are changing this millimeter to meter, so it means millimeter to meter means this means the division. So here the number, the height is, this is 650, so you have to divide this number by 10 to the power 3, so it will be 0.650, and this height in meter is 0.650 meter. So here you have to find the pressure. So the pressure formula here, I told you this is the pressure formula. So this pressure is equal to HdG, and the value of the H is 0.650, and the G is constant. It will be given to you, and the value I am writing here, this is 13,600 kilogram over meter cube, and the value of the G is 9.8. So this is the value of the D, this is the value of the D, and this is the value of the G. This will be given to you. Now here if I calculate this one, so it will come 8662 Pascal. So this will come in the unit of Pascal like this. So here this is the answer. So here in this question, a nitrogen gas occupies a volume of, so this is the volume value in millimeter cube, in the unit of millimeter cube, at a pressure of 700 megapascal. So this is the value of the pressure, and the temperature is minus 200 degrees centigrade. Determine the volume. So this volume you have to find of the gas at 1.5 degrees centigrade. So again this is the pressure value. If the pressure is increased to 800 megapascal, so again this is the pressure. Now here how many parameters are given? This is one parameter, and this is second parameter, this is third parameter, this volume 4 parameter, this is 5 parameter, this is 6 parameter. So here 6 parameters are given, and this I'm writing all the 6 parameters here. So the initial, this is the initial information. The first one is the initial information. So here the volume, the initial volume is given. This is 1000 in the unit of the millimeter cube, and the pressure, the initial pressure is given. This is 700 megapascal. This is capital M, the megapascal, not the small m. This is megapascal. So I can delete this. So here this is the capital M, so this is megapascal, not the small m. So it is a megapascal, and the temperature, the initial temperature is given. This is minus 200 degrees centigrade, and the volume, so this is the final volume. This you have to find, this volume you have to find out, and the temperature, the final temperature is given. This is 1.5 degrees centigrade, and the final pressure is given. This is 800 megapascal. Now these are the given parameters, and this volume you have to find. Now you have to choose the formula, which formula you have to choose. Now what the formulas you can use here? The formulas you can use here, you can use the Boyle's law, and you can use the Charles law, you can use the Gay-Lussac law, you can use the equation PV is equal to nRT, like this. So here, if you cannot use the Boyle's law here, because here in the Boyle's law this volume is this temperature is constant there in the Boyle's law, and in the Charles law the pressure is constant. So, and in the Gay-Lussac law this volume is constant, but here we have to check any parameter is constant or it is not constant. Now this volume you have to find, so it's okay. So here the value of the initial pressure is given. It is given 700 megapascal, and here it is 800 megapascal. So this is not same. And here the temperature is given. This is minus 200 degrees centigrade, and here it is 1.5 degrees centigrade. So the temperature is also not constant, and the volume you have to find. The meaning is here all, okay, here all 6 parameters are different. There is no any uh, uh, same parameter. If you see, this is the initial parameters, this is the initial parameter, and here these are the final parameters. So there is all 6 parameters are different. So here you cannot use this rule. You cannot use the Boyle's law, you cannot use the Charles law, you cannot use the Gay-Lussac law, and this the ideal gas equation also you cannot use. So here you have to use the characteristic gas equation. So this characteristic gas equation you have to use, and the formula for the characteristic gas equation is, it is Pi and it is Vi, and here it is Ti is equal to, this is Pf and this is Vf, and here this is Tf. So this formula you have to use to find the value of this, the final volume. But the values we have to put here in this formula in the standard units. Now if we come to this parameter here, this initial volume is in millimeter, so this we cannot use in millimeter cube. We have to change this to meter cube, and this is megapascal. This megapascal also we cannot use. Degree centigrade change to Kelvin, and here also this degree centigrade change to Kelvin. This megapascal also we have to change to Pascal. So these changes we have to do in all the units. Now we have to change first this volume, the initial volume, to the meter cube. So this is, here this is initial volume, and this is, it is given 1000 millimeter cube, and the relation between the meter cube and the millimeter cube is that 1 meter cube is equal to 10 to the power 9 millimeter cube. Now because we are changing millimeter cube to meter cube, so we will divide by this number, and here this is the initial volume is, it is 1000 divided by 10 to the power 9, and it will be 1000, and this will be 10 to the power minus 9, and here this will be meter cube. So this way we can change. Now this is this one parameter we are getting, the initial volume, and now the initial pressure. So this initial pressure is 700 megapascal. So this mega we have to change. So the value of the mega is 10 to the power 6, and this is Pascal. So this is the value of the initial pressure, and the initial temperature is, it is 200 degree centigrade. So what to do? Just you plus number 273. So it will be converted to the Kelvin, and it is 73 Kelvin. The value of the Ti is this one, and the TF is given. This is 1.5 degree centigrade. So you plus 273. So it will be 274.5 Kelvin. So this is the value of the TF. Now we will move to the another the pressure value. So this pressure, it is given 800 megapascal. So this mega we have to change. So this is 800 multiplied by 10 to the power 6, and this is Pascal. So this is the value of the PF. Now we will use the formula, the rule, the rule for this. The rule for this is, this is Pi and this is Vi and this is Ti. It is equal to, this is Pf and this is Vf over this is Tf. Now we have to find this Vf. So what you do, you cross multiply, okay, like this, multiply this and then you multiply these two things like this way. So here it will come, if I multiply these two, so it will come like this. It is Tf and it is Pf and this is Vf. It is equal to, it is Pi, this is Vi, and here it is Tf. And because we have to find this, so hold this here. So this is Vf is equal to, this is Pi, it is Vi, and this is Tf, and here this, what is the remaining thing here? This is the remaining thing here. This is multiply with this Vf. So this parameter will go downside. So here it will go down. So this is Ti and here it is Pf. So this form of the formula you have to use to find the value of the Vf. So now you have to find the value of the Vf. So here the Vf, the formula for the Vf is this, Vf equal to, this is Pi, I am writing again, this is Pi, Vi, and this is Tf, and divided by, this is Ti, and this is Pf. So write all the values here. The Pi value is, this is 700 into 10 to the power 6, and the Vi is 1000 multiplied by 10 to the power minus 9, and this is Tf. The value of the Tf is 274.5, and this will be divided by the Ti is 73 and multiply by 800, the pressure value, final pressure value 800, 10 to the power 6. So whenever you are calculating this these numbers, so you take the bracket here, don't forget to use the bracket in the calculator. So here like this, keep the bracket here. So after the calculation, this value of the Vf, it will come, this is 3.2 into 10 to the power minus 6, and the unit will come meter cube. So this is the answer here, answer of the final volume in meter cube. But as an example, this is the answer, this is the actual answer of this. But as an example, if the question says that you find the value, you find this Vf in the unit of liter. So what to do? You have to change this meter cube into liter. So the relation for the liter and the meter cube is that 1 liter is equal to 10 to the power minus 3, and this is meter cube. So now you are changing this meter cube to liter. So you have to divide by this number. So here the number for the volume is this one in the unit of this meter cube. So what to do? This VF, so this is 3.2 into 10 to the power minus 6, and it will be divided by 10 to the power minus 3. So when you will solve this, it will go upside, it will take plus 3, and this will be 3.2, and it is 10 to the power, it is minus 3 liter. So now the final volume, this number is coming in the liter, and this number is coming in the unit of meter cube. This is the difference. Sometimes the question may say you find the value of the volume in so and so unit, but if whenever you are using this formula, by default you will get the answer of this volume in meter cube. After that you can change whatever the question is saying. Suppose if the question is saying find in liter, so this way you have to find in liter. Let us suppose if the question says you find this volume in the unit of milliliter. So first you have to change this to liter like this, and then this liter to milliliter. So milliliter means if this, like from here I can see here, like this is, it is coming 10 to the power minus 3. So this 10 to the power minus 3 means it is a milli. So in milli, so I add this value, I can write this is 3.2, and this is milli. Milli means for this number milli, and this is liter. So this is the value of the volume in milliliter. In milliliter, this number is coming in liter, and this number is coming in meter cube, like this way. Now thanks for the presentation. Thank you very much.